Okay, this took a while to get here. He walked back into a bike trail that no one seems to know where it was. That I asked, and the guy lived right by it. But I just took a gamble that it would be a bike off this bike trail. And here's the ARCHED Bridge, circa 1856. Beautiful. Let me put down my iPad. Got it with me. Let's go take a look at it. So it's archway, brick and stone. Wow, it's beautiful. It's skewed design, the way they do it on an off. Let me see. Refer to it as a skewed design. This is going off and away to that direction. Offset. Beautiful. Somebody's lit some candles up here and things like that. 1856. Hey, hello, somebody. Hopefully I won't lose you. I'm walking to this skewed design 1856 bridge structure. Maybe I should not go in yet. Let me get a quick height on it. Put my laser along. Oh, not as high as it. It's only about 16 feet tall. The skewed design archway bridge. It's a irregular shape. It goes, you know, like a cathedral ceiling. Not. Well, I'm gonna try to go in here. Hopefully, I'll back out if it starts losing signal. There's the brick archway. Look at it. Beautiful. The courses on them are. The course thicknesses. Look at the courses of them. Hey, Hermit. This time you caught me. Look. This is skewed bridge, 1856. You can look it up. I put it in the description. Hopefully, it's in there. It's brickwork. It's an abandoned structure. They don't use it anymore. And the skewed design. Look how it herringbones, how it goes over each other. Well, that's not a herringbone, is it? But look how it overlaps. Looks like Europe. Hey, Tom. Yeah, Philadelphia, man. I got it made with the bridges, my resources. I think I'm going to have to do a lot more bridge videos. This is, you know, this is very interesting that other people. I guess I thought I was a nut job. I thought I was the only one that liked, you know, bridges. So I'm not as crazy as I thought. They'd have to commit a lot more people besides me in that place when we stopped by and visited. Anyway, the stone exterior, and then they did this Ultima. Looks like a closure. What's the word? I can't read it. Come on. Oh, gotcha. Oh, nope. Gone again. My screen bounced away to comments. Gotta wait for it. I had to back up to get the comments come back. Before waiting for the load. I'm gonna go here. I'll back out if it starts losing signal. But look how they change directions also. So we can see them on this face. We can't see this face. This face is seen the other direction. Bridge troll. That's right. Me, yeah, Tom, cool. Me, I do it for the old engineering of it, the 1800 stuff. And look at the abutments, if you will. Each one of these act as an abutment. And it's got tons of soil behind it, you know, but many abutments. Look at the shape of it too, they did. And how they fill it in. Each one of them consistent. Let's see how consistent they are. 1, 2, 3, 4, 5. This one's got 4 in it. 1, 2, 3, 4. This one has 5. 1, 2, 3, 4, 5. It's okay. I mean, it's awesome. I don't think so. I think it's all archway, all brick, all under compression. You got a little. Here's probably a transition to the center of the bridge, where they transition out. But now you see these facing us. It's beautiful. You have to walk to this. It's abandoned, as you can see. The road is long gone. 1856. Imagine the people that went through here. And then when we get to the other side, we're going to see a mirror image of it, hopefully like stone. And then here we go. Here's your stone. I'll take us up onto the deck too. I think it was a trolley bridge for the trolley to go through. And look at it. You know, it's not the radius. See the effect it gives of the arch like this, like it's crowned differently. But if you take into each individual arch on a 90 degree, if you will, like this, you'll see that the skew effect is an illusion of it being off. This is a perfect radius, if you will. The next one's a perfect radius. But because you we offset them. It gives a skewed look. Hey, Herman. Yep. Yeah, I see you coming down. Perfect. So it gives a skewed look. But in reality, each one's perfectly done all the way over. Look at the candles. People light this up. I mean, each one has there's candles over here. That must be on too. I wish I bought my matches. I'd light that shit up. The trees, the test of time. This is like a 200-year-old bridge hasn't taken it out. We'll go to this side. Well, it's just amazing. And here we got 1, 2, 3, 4. Ceiling height on this is about 16 feet. Let me check it real quickly with the laser. Let me do it again. It's, that can't be right. Let me see. Yeah, I'm reading 15. Let me do that again. 15 feet, and if I come down, I'm probably going to get right about there. You guys might be able to see the laser. Let's see. Yeah, you can see the laser now. That's better. It's staying on. So I'm taking a measurement using the laser here, right about the center point of this arch. So remember the arch, I'm giving it that skewed look. If I came 90 degrees to this, it would be just a perfect arch. It would not be a offset arch, as you will. Square it to this one. Now let's go back in here and get this height right about the center of the structure. 15, 11, 16 feet. I'll put this one online. I'll leave it online because I don't think anyone has a video of this bridge and what's my, yeah. Now let's go and let's see what the top part looks like. There's my boss. Oh, almost bust my ass. Okay, here we go. Let's see what she looks like. So it's stone. As we still come up this thing, imagine the stone they had to move, you know? Wow. Oh, it's got grouting in it also. And right about there's the decking, because I can see the grass all the way through. See if you guys can see it. See the daylight? So we got, well, without even going to the other side yet, we know this is probably the railing, if you will, the wall. So let's see what we got. Okay, back up to the trail. Here's the entrance of the same bridge. Tapping it clearly, get focusing it now. Here's the entrance. Let me clamp on my tripod. It helps with the stability, I think. Oh, we're right now. Here's the bridge. We're, well, probably on it right about here somewhere. Here's some brick. Huh. We can clearly see the arches aren't collapsing below, but yet this surface up here, this wear surface, is so irregular. It's all over the place. There's the edge of the, over here is the edge of the, this abutment. Now it's skewed, so this is one end, the other end is over there. And this end would be closer at this point, and the further end would be there. And this was the trolley cars. So we're looking at somewhere tracks, I guess, on the ground here, somewhere buried or gone. And there's the other, it's behind these woods, there's the, behind this brush is the other end, which is over here. I'll go down that side and show it to you, since we already did that side. Here it is, coming up on it. You'll see it in clarity in a minute. Here we go. So here it is, here's the top edge. Let's walk it a little bit. Let me clear my sandals. So if I fall 17 feet, well, I guess it's more than 16 feet because this had a roof on it. Probably drop. And don't worry, I don't believe it would be that much painful. Not until I start screaming. Then the pain's there. And I don't believe death is painful anyway, so. Let's take the height down to the ground, the depth to the ground. I said 30, I'm still at 15, hold on. 22 feet, 23 feet, 23 feet. It's not bad. That's at that location. Let's see if we can pull up what we get here. I'm still crushing on my 30 feet, so let's see. Come on. My strap's getting in the way. Just nailed it. Look at that perfectly. Still 22 feet. So 23. Sorry, 22.11. 23. Previous it was same thing. 22. So I'll take you one more time into the bottom of that bridge. You see what it looks like up top. I can see why they'd make a little bridge, you know. It's just that it'd be a big dip. They had to come down back then on the trolley, right? They'd have to dip down and come back up to get to the surfers up top. This is interesting. You know, it's abandoned altogether, and yet this was obviously 1856. This was open real estate to access. And we'll go down this side to access it. Let me get the width of it. This is going to put this online for everybody to take a venture out here to take a look at it. Let's see what the width. I'm standing by the one edge. I'll shoot the other edge kind of askew, as they say, on an angle. Let me get the angle going here. Let me step over a little further. Trying to get the width from here to the other abutment, or the other side of the bridge. Okay, I got it. The laser's there. 38 feet. 38 feet, 11, 5/16. 39 feet from face to face. You can add the extra stone if you want to do the outside of this. And I don't want to step on that. Let me show you that one more time. Look how beautiful that stonework is again. Apparently it's the same stone. Look at the texture, the carving on each side. All the way around on both sides. So they finished, in other words, it's got finish on both sides. Oh, interesting. They put some filter fabric up here at one time to keep the earth stable. Okay. What we got here? Comment, you make a great teacher, a tough master. I can't read it. Can't read the rest of it. Thank you. Thank you, Jason 5. Jason at 5. Jason at 5. Don't do that. I don't see the post-tension tubes. Yeah, this is 1856, you know? That's what I find amazing, is that this stuff, you know, we keep playing around with technologies that aren't working. That's rebar. That'll hurt me too, coming down the hill and hit that. Look, and it's through some wood. So wood, they had to push that through the wood. No, of course not. The wood grew around this. I'm gonna move it out of the way so no one else gets impaled. Let me move it, maybe someone will clean the trail up and they'll see that. I'll put it over there. All right, so back structure. It's beautiful. It's what new people just popped in on a video. This is an 1856 skewed arched bridge, combination of stone and brickwork. Let's get out of the light. I know it's glaring on you. And let me get a couple more feet. There we go. And so, as I said earlier, how do you get the skew? The skew, again, 90 degrees. And you just start stepping it back. So each one is parallel from each other. And your setback is the difference from this one to the face of that one. If I could square off of that, roughly, squaring off of to see how much of a setback, this is parallel, right? These two are parallel. So if I do a 90 off of that, say that's roughly a 90 over there, I could tell you how far the skew is. So we'll do a little piece of wood there. That's my kind of sustainability, right? So then we back up to the edge of here, and we see how much it's skewed by. My laser on it. Oh, wait a minute. Let me zoom in for you guys to see how accurate the laser is. Now I'm elevated a little bit. I'm trying to look through the camera at the same time so you guys can see it. Take a reading. I got 28 feet. Let me take another reading. And I'm trying to look through the camera at the same time. "28 feet. And let's do it again. I'm coming down a little lower, a lot lower. Because I figure I'm not coming back here. People around the country might want to see it and might get curious about its dimensions. I keep coming up with 28 feet. And one more time. And I'm pretty low. This gave me an error. It's skipping the lasers. You know what? There's a bottle there. Hopefully the bottle's not reflective because it's yeah. Here we go. Ah, fucking D. Oh, fuck me. I turned over a fucking hornet's nest or something. Over there. Oh, stung the hell out of my leg. Oh, that one's on the house. That fucker. One more time, take a reading. Oh, you bastard. Sting like a son of a bitch. Killing me here. Okay, I'm coming to 34. And then from point to point, so let me zoom this out. Roman graffiti, yeah. Make sure I'm zoomed out. Whew. So from here to there, that angle. It's also got a level on it. So I can get pretty, come on. Can't do anything if I can't see it. Okay, I'm there. Got 37. 37.7. Yeah. So there's my, whatever put a needle in me. Whatever that was. Probably a carpenter bee. Those damn things got, I tell you, they got a nail they use. They don't even bother using anything else. And there they are underneath that piece of wood I grabbed. All right, so back to this. There's your skew design. Awesome. I guess I played it out. There's the other side. We went up one side. I'm sort of, I was threatened over there, so I'm kind of scared going up that side. And there it is. And there's your keyway, your keystone. The literal keystone in the center. Coming around. Look at the holes that they put in it for, I guess, when they were doing their chiseling or strapping or whatever. Because look, you see the piece of metal? Let me zoom in for you guys. Where are you? Yeah, okay, there we go. Some old iron. And let's see what I can get back here for you. I see some, look out for my brother bees. Okay, so there's your abutment again. So each one of these arches have a mini abutment of stone, but look how beautifully it's carved too. And each one of them apparently are matching angles. I can't reach it. I'll give us an angle on that. I might be able to scam an angle by using the laser line. Yeah, by using the laser line as path to tell you. So there's that one. Coming up 45 degrees. 45. .43, but it's still 45, right? How big are the bricks? Yeah. Look like your standard 1856 bricks. You remember when we were using those last week? 1856 bricks. Well, I guess, but I got it from, if I can find it, maybe not joking this time. Might be able to find a date on one of them. So that's an excellent point to bring up. Let's see if I can do that, Hermit, without getting stung, because I'm going to look on the other side. A date. And that's interesting. I don't find a date on this bridge at all. And I think that's one of the problems. The date of 1856 is about what, no one's arguing. I guess you can call it 1850 or 1890 even. No, I don't know. You'd have to follow the trolley. Oh, look at that. Look at the, let me give you a laser. Look at the, oh, hold on. There we go. Look at the shape of the back of the stones and how they marry the brick to it. And I have a video that I didn't post because I figured I'd get really beat up on it. But I was showing that don't get too crazy and carried away with things being off. Like that's not being perfectly cut even with this. Because it still makes up for it. It's still the intent is still being taken place, even this little curvature. It's still taking place. And the video was showing that you can basically put brick together in almost any shape. As long as they're contacting, you're going to still get brick and block. You're getting to transferring the loads. Now look at these guys here. They've got mortar joints in them on the outside. We don't know what they have on the inside. What's going on there. How deep is this really? I don't know. You'd have to sacrifice a spot and dig into it to see how far it goes back. Let's see if we get lucky on that. Again, this looks like the 45-degree stuff. I'm looking for that date. Anything stands out. Well, let's look at the depth of each one of these now. So this one is 1, 2, 3, 4, 5, 6, 7, 8. Then we go to the depth of this one. 1, 2, 3, 4, 5, 6, 7, 8. Let's back it up 1. 1, 2, 3, 4, 5, 6, 7, 8. And its sister one is over here. And let's check the depth of that. 1, 2, 3, 4, 5, 6, 7, 8. And about the same. And checking the other one. 1, 2, 3, 4, 5, 6. So about eight bricks turned on the side with a grouted joint. 1, 2, 3, 4, 5. Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 8. Now let's give you a depth of that. I think I can reach that without getting kicked. Let's see. I better come over here a little bit. 33 foot. Okay, so I've got 3 foot. Let me give you a little data. Come on. 3 foot 1 inch is what it says. Let's try this. Here we go. 3 foot 1 inch. And what did you say? The bricks are in good shape. No frost. Yeah, nothing's getting under here. No frost damage. What do you notice? No effervescence. You don't have the problem with concrete. Concrete wants to do all types of crazy things, but look how stable this is. I mean, it's just beautiful. Arches are just beautiful. Everything in compression. There is no cement here. This just dry stack, perfectly flat facing each other, and the loads transfer in compression all the way down to here. And here's your abutment, if you will. And so that was 3 feet. What's our abutment on this time? I'm all gun shy about this damn bees and everything else. Well, all right. So we check this one, and cool. I can actually give you the angle here now too. Hold on, guys. I know it's getting you. I'm coming up about 40 degrees now. 40 to 40. Come on, get on there. I gotta make sure the reveal's about the same. Just guesstimating. No, it's 45. And I got 2 foot 9 inches. So I have 2 foot 9 from here to here. So it's the same thing, right? The other one was like 3 feet, I think. And it's a 45 degree. So you've got enough. Now I'll give you the width of the archway from here to here, since I can do that from this side. And I've already been up this side, so I feel kind of... Let's be realistic. There we go. And let me get a depth from here over to the other side. And it triggered at 38 feet. 38 feet 2 inches. 38.2. 38.3, 32.5. Let's do it again. Round 2, right about the edge equal there. Whoops, too high. Lower one. So 38.6. I like that one better. I think I was up here. 6 on the bottom arch. So 38.6, and let's come to the center. There's a keyway. This considered a keyway is on the money. The problem is my ground's not flat. It's on a, as you can see, the ground's on this erosion came down. So I won't be able to get a proper height from there down. So I'm gonna go to the other one and take that height. And we're going to guesstimate that all these are 38.6 across. And we can verify that one of them if I can get a little taller in height. So I'm going to try to use this one for my theory of verification, right? Coming over to there. I'm sorry, it's going to get long. Wait a minute, no, that should be the same. All right, so go ahead. Just give me a second here. Yeah, it's about the same. 35 it came up with. Got 38 on the front. Come on. 36 rather. Let me do that. Got to get it in some different lighting. Great. Come on. Here we go. I realized what was going on with the sensor now. So we've got 35, 36. I'm going to do another one just for verification. Come over. Same one. I keep an eye on the dot over there. I'm going to keep an eye on this time. I'm going to move it a little higher with my hand. Oh, there you guys go. Got a reading. 36. Come on, catch up, sensor. 36. All right. There we go. So, will we have 36 down here? Did they somehow manage to skew this? Gosh, damn it. Another friggin' bee. I'm going over there, bees. I'm getting that measurement, so kiss my ass. Okay, I'll take it from the other side. They win. Okay. This is what's going on. This setback, this one's further back, it appears, from, oh, let me zoom out. Your setback from here to here, it would be from here to here, except for now we have this extra void spot that's an additional setback that makes the entrance wider. Now let's get the height of it. This ground looks pretty eyeball level. Let's get the center. So your arch was what, 38 feet? Now let's get your center of the archway. Let me check my level on this. 8 degrees off. Nope. 90. Okay, I've got nothing. 16 feet. Second reading, 16.5. So got within 230 seconds of each reading. The one above it is the one reading, the one below it is the second reading. So 16.5, 16.5 and 16.5, 30 seconds, and 16.5 and 30 seconds. So 16.5. So now you can figure out this radius. You got 16.5 going up. Radius it, you get your 32 feet roughly. Oh, it's pretty badass. All right. I think let's take a look from the back side of it again as we hold off on it. So now you understand how you get that when you use a skew bridge, how you get that look, that ceiling look of like it's almost like a cathedral A-frame, if you will, but it's not. It's multiple layers of the just one radius skewed off. All right, thanks guys. I'll load up again when I get to another bridge. So I'm saying goodbye to you. Holes for drainage must be relative free of water traps as an ice dam. Okay, I'm reading that now. Sorry, Rick. Yeah, water just runs right through it. Good point. Yeah, the bricks, I can't figure them out. 4 by, well, you do the math. There was 8 bricks, and I did the length of it. And you know the length that way. I guess I didn't give us this other length, though. I didn't give us the length, this brick going over, from here over. 1, 2, 3, 1, 3.5. Let's see if I can get it. Not from here. I gotta go down the other end. I'll make the trip. Get you your brick measurement. You know, come this far, and you guys are so far away watching. Don't be afraid to ask me to do this. You know, don't feel out of place. Hell, when else are we gonna get an opportunity to do this, right? So over here, I want to get the depth. And let's see. I think I did this one, did I? Did one of these? No, I did the other angle. 2 foot, 2.6. Give it a second. 2.6. 2.6 and a 2.6. And there was a 2.6 this way too, or was it close to 3 feet? And we're gonna do that one. Oops. 3 feet, yeah, that was 3 feet. 3 feet. 2.6, one dimension, 3 foot the other dimension. And there's your archway. Just a bunch of bricks, right? A bunch of bricks. You get a 200-year-old bridge with a bunch of bricks and archways. Why are we doing things so friggin' hard these days? Why are we not doing it so simply like this? I'll tell you. All right. Take care, guys. Cheerio. Thanks, Hermit. And I'll see you on the next one.